Let's do another example of how Lenz's law works. We'll skip case 2 and skip in case 3, and we will go to case 4, where we are pulling the south pole of a magnet out and away from a coil of wire. As this south pole moves further away, this magnetic field line up here, which is now going through the coil, is going to eventually move over here where it's going to miss the coil. It will no longer be going through it. That means there is a decrease in the number of field lines that are going through this loop. So when we start to ask our questions in order to go through the Lenz's law process, first question is, what is changing? And we have figured out that the magnetic field strength through the loop is changing because there are going to be fewer and fewer magnetic field lines going through the loop. So this is a decrease in the amount of magnetic field strength that's going through the loop. Now that we know what's changing, how is the flux changing? If you have decreased magnetic field strength going through the loop, then the magnetic flux is going to be decreasing. Okay, what opposes a decrease? An increase opposes a decrease. So in order to oppose this change in flux, we actually want to try to increase the flux with the new magnetic field that is being induced in this loop. So, how do you have to point that new magnetic field that's being created by the current going around in the loop? That new magnetic field has to point to oppose the change in flux. The change in flux is a decrease. We need to have the new magnetic field point in a way that increases the flux. So the new magnetic field actually has to point in the same direction as the original magnetic field. And this is where Lenz's law leads us in the right direction and tells us that you don't always have the new magnetic field pointing against the direction of the original magnetic field. You can have a case where the new magnetic field is pointing in the same direction as the original magnetic field. Okay, final step is, what direction do you have the current going in order to make a new magnetic field that points in the direction you just figured out up here? All right, if this is the close side of the loop and this is the further side of the loop, and I want a magnetic field to go off to the left, my thumb is that magnetic field going off to the left on my right hand. My fingers are going to point upward on this close side of the loop and downward on the opposite side of the loop. That means from this perspective, with this loop tilted a little bit like this in the diagram, the current would have to go up this side and down that side. So if current is going to be moving up this way and then down this side, from this perspective, that's going to be a counterclockwise direction by the right-hand rule.